Liftoff in 5, 4, 3, 2, 1, 0. And liftoff.
That's exactly what our tour today focuses on, the launching of rockets and humans as part of the Commercial Crew program. Commercial Crew is focused on safely getting humans to and from the International Space Station with our partners Boeing and SpaceX. Hi, I'm Joshua Santora. Thanks for joining me here today on the sunny coast of Central Florida at the Kennedy Space Center. Our tour today has two main stops. The first is over there. It's Launch Complex 39A, or LC-39A. This has been where SpaceX launched a number of Falcon 9s, its Falcon Heavy, and soon humans on board the Crew Dragon. Our second stop is actually a little further south, on Cape Canaveral Air Force Station property. It's United Launch Alliance's Space Launch Complex 41, or SLC 41. It has been the site of such historic launches as the New Horizons spacecraft, which flew past Pluto, the Mars Science Laboratory Curiosity rover, and soon humans on board the Starliner. We've got a lot of ground to cover today. Let's get going. You might recognize this. It's a Falcon core stage. They're used for both the Falcon 9s and the Falcon Heavy rocket. All SpaceX rockets are designed and built at their headquarters in California before being transported to their rocket development facility in McGregor, Texas for engine testing, and then finally here to the Kennedy Space Center or to another SpaceX launch site. The Falcon 9, which will be used for the Commercial Crew launches, has been used by SpaceX on over 50 successful flights since 2010. Equipped with 9 Merlin 1D engines, each Falcon 9 packs over 1.7 million pounds of thrust. We love redundancy, and that's a huge plus for this configuration, as they're able to experience up to 2 engine shutdowns and still succeed. After launch, once the first stage is depleted of fuel, it will separate and return to Earth, releasing the second stage, which has its own Merlin vacuum engine, to continue on to orbit. For fuel, both the first and second stages use rocket-grade kerosene, and both stages carry supercooled liquid oxygen as their oxidizer, since there's no oxygen in space. The Falcon boosters have the ability to land and be reused, and to assist with reusability, they have a few special features. The first is the Hypersonic Grid Fin. There are 4 of them that will mount towards the top of the rocket, and those help steer as it re-enters the Earth's atmosphere. There's also the carbon fiber landing legs. There's 2 on the floor behind you. Those will be installed near the bottom of the rocket, and they deploy just before landing. Reusability goes a really long way to helping reduce the cost of access to space. But recovering a booster is always secondary to ensuring the spacecraft gets to the correct destination in space. Now, we don't launch indoors, and we certainly don't launch horizontally. So, when the time is right, the main hangar door will open, and the transporter erector, or TE, will move into the building. The rocket will be secured on top, and then the rocket with the TE will both roll up to the top of the launch pad. Let's head out there and take a closer look. Once the Falcon 9 finishes making the trip to the top of the launch pad, the TE will then lift the entire rocket into a vertical position. Final checkout takes place, and for Commercial Crew launches, when the time is right, the astronauts make their way out here, travel up the tower, across the Crew Access Arm, and into the Crew Dragon. The launch will be controlled and monitored closely by SpaceX personnel here at their Launch and Landing Control Center and in Hawthorne, California at their Mission Control Center, as well as by NASA personnel at the Kennedy Space Center and the Johnson Space Center in Houston, Texas. All of these teams have to work together to ensure all systems are working and ready for flight. The launch team conducts a go, no-go poll prior to final countdown. Then, after the engines ignite, the launch mount briefly holds onto the rocket for the flight computers to do a final check before releasing the rocket for liftoff, beginning the astronauts' trip into space. Now, let's head over and see how Boeing is doing their launch prep. We're out here at SLC 41 now. We're there in the process right now of making modifications to be ready for Commercial Crew launches. One of the things we had in mind when we selected 2 partners was diversity. Diversity of thought, opinion, approach, perspective, execution, and innovation. Boeing and SpaceX are doing things differently, and we love that. For Boeing, they wanted to focus on creating an amazing space capsule, and so they're working to fly on top of a proven rocket. They're working with United Launch Alliance, or ULA, to fly on top of the Atlas V. The Atlas V is an industry-leading workhorse that's been flying for more than 15 years and has over 80 flights to its name, every single one successful. The Atlas V also has a variety of configurations to meet the needs of its many customers, and they've got one ready just for the Starliner. They're calling it the N22. The N means that there's no payload fairing because there's a capsule. The first 2 represents the 2 solid rocket boosters on the first stage. The second 2 represents the 2 engines on the upper stage, or Centaur. The 2 solid rocket boosters, plus the RD-180 engine on the first stage, will produce more than 1.4 million pounds of thrust at liftoff. That Atlas V will actually arrive here horizontally down that road, and it will travel to that facility, the vertical integration facility. And they'll tip it from horizontal to vertical, and then they'll hoist the Starliner on top and secure it in place. Once final checkout has happened and preparation is complete, they'll actually roll that entire stack down rails to here on top of this mobile launcher platform to be ready for launch. Let's head up and take a look at the view the astronauts will have as they prepare to board Starliner. The progress and preparation for these commercial crew launches will be monitored closely by ULA, Boeing, and NASA from across the country. Some will be here in Florida at the Atlas Spaceflight Operations Center or Boeing Mission Control Center down that way. Others will be in Houston, Texas at the Johnson Space Center in Mission Control. Several hours prior to launch, the entire area will be cleared of all personnel for fueling to take place. The Atlas V uses liquid oxygen and rocket-grade kerosene as its fuel. Once that fueling is complete and it's safe to return here, the astronauts will arrive and travel up an elevator in that tower to this level. They'll walk across this, the crew access arm, the last place they'll set foot before blasting off into space. A similar process was followed for the Space Shuttle program. Every launch pad on Earth that launches humans has what's called a white room. The white room here is actually through those double doors. It's the part of the crew access arm that connects directly to the spacecraft and allows for easy access by the astronauts and their support personnel. It also is extremely clean to make sure we don't contaminate the vehicle. Once the astronauts are strapped in place and safe, the entire area will again be cleared of all personnel, except those on board, of course. This crew access arm will be swung out of the way of the rocket, and at T-0, the engines ignite, and we're off. If all goes according to plan, when those rockets leave Earth, it will only take about 8 minutes for them to reach orbit. And a day or so later, they'll be able to rendezvous with the International Space Station. Both of our commercial crew partners have spent a lot of time planning individualized approaches that have resulted in really unique hardware. On the most fundamental level, force equals mass times acceleration. Gravity isn't changing, and each partner knows exactly how much their spacecraft weighs. The difference in weight means that they'll need a different amount of force at liftoff. They'll have to get the math just right in order to reach their destination. If you haven't ever had a chance to see a launch in person, I hope you'll find a way to do that soon. And if you can't make it out here, I hope you'll tune in online. And keep your eyes open for opportunities to view in virtual reality. We'll see you next time as we prepare to launch America.
Hello, I'm Kathy Leaders, Commercial Crew Program Manager. Thank you for taking a tour today with Commercial Crew.